and turn instead to our colleague John Gostick, who's at Cambridge University Library. John's got all sorts of interesting things to tell us about their ingest workflow into an AWS Cloud. So, John, you look like you're set. I saw your screen light up, so you're ready to go?
I think so, yeah. Let me just share the screen. Can you see that okay?
Not yet.
Oh, no, so I need to click share as well as select it. There we go.
Now definitely can. Okay, and I can hear you fine, so it's all
Can you fine?
yours.
Excellent. Okay. Am I working to 25 minutes? 20 minutes?
If you can get up to the sort of top of the hour, that would be good. Yeah.
Brilliant. Okay. Okay. Well, hi everyone. My name's John Gostick. I am the technical lead for digital preservation at Cambridge University Library. Today I'll be talking about some of the ingest workflows that we've built or are building for our DPS or digital preservation service. So what is the DPS? A quick bit of background. It's a digital preservation service, as mentioned. It's part of a 5-year digital preservation program that we're running at the library. And the high-level goals include having a central place to store and manage digital assets, make various improvements or build end-to-end workflows that help reduce the amount of manual steps, migrate many of our sort of on-prem applications to the cloud, so not strictly digital preservation, but all part of the program, and just generally bring in improvements to search, discovery, and access across our collections, which can be quite disparate. So conceptually, the basic model looks like this. We acquire content from various sources. We put it through a pre-ingest stage leading into ingest, which I'll go into in a minute. And that flows into a central repository with administration functions, additional functions underlying that for preservation and preservation storage, and obviously access for staff and users. So I keep clicking the wrong thing. In actual implementation, the overall DPS looks a bit more like this. So again, you can see from the diagram that expands on the various areas previously mentioned. In terms of acquisition, we have Apollo, which is an export process, which I'm going to go into in a minute, from our institutional repository, and that feeds into the workflow I'll be describing. And then we've got others like our transfer service for extracting media from, digital files from physical carriers, and then our deposit service for actually collecting digital deposits, and another one for our digitized images workflow. Few other things to mention: this runs entirely in the cloud. So everything is built to be cloud native where possible, to take advantage of the sort of scaling capabilities, the economies of scale, especially for storage, and various other benefits that cloud platforms can offer, such as software-defined architecture. So we're not going to drill too deeply today, but everything that you see here can basically be spun up from what's called a Terraform script. Basically, infrastructure as code. Everything is defined in that code, and you just run it, and it deploys it, which is very cool. And where possible, well, exclusively, we're using open source software and open standards, and the code that we're actually writing ourselves, we plan to open source towards the end of the program. So this is all built around Fedora 6 repository at the core. So just to briefly do a quick plug for Fedora, this is a flexible, standards-based open source repository software. It's built to support long-term digital preservation, and to sort of store, manage, and preserve digital content. And for example, one of the features we lean on heavily is it supports the OCFL Oxford Common file layout on an Amazon S3 store, which is cloud storage. Now, Fedora is, I think, what you class as middleware, so you can interface with it directly as a human, but it needs programmatic integration. In other words, like an application or a script to talk to it, to actually use it properly and take advantage of all of its features. And so this is where our ingest workflow comes in. Just highlighting where it sits in the architecture. So our first ingest workflow that went live was for a specific content stream, because we wanted to start simple and go from there. So the MVP, the minimum viable product that we built, was back in 2023, was for e-theses content specifically. So the workflow basically ingests archival information packages, APEs, that get exported from our institutional repository. It unpacks them and then it stores the content and metadata in Fedora. And then we have a separate flow which copies the underlying OCFL data which Fedora creates into additional preservation stores. So we have copies. As mentioned, this is all cloud native, serverless, event driven. Those terms might not mean anything to you. I can expand on them later if required. But crucially, the workflow is automatically triggered and effectively spins down. It's not running when we're not using it, so it doesn't cost anything. It's like pay as you go. Only when we actually need to use it does it actually cost anything. We ingested approximately 1.2 terabytes of data through this workflow back in February last year, and we've been in sort of a BAU process since November this year. Apologies if you can hear my dog in the background. The delivery man's just off. And we have a version 2 for additional streams coming soon, which I'll go into in a moment. So to trigger the workflow, we have a separate process for content submission. And this is sort of specific to our DSpace software, which is the software which underpins our institutional repository. But you can probably see from that, on the left, we have the actual on-prem server. There is a process in place to produce APE packages. And that same process also takes care of detecting when there are differences and creating APEs accordingly. Every time a package is updated locally, we have a synchronization process which copies it up into the cloud, specifically into what's called an S3 bucket. So this is a cloud concept or object storage. The act of copying something into that bucket creates an event, and that event in turn triggers a little bit of code called the Lambda, and that basically checks the name of that file against the known list of ETCs identifiers, and then if it is one, it puts it in another bucket, which then triggers the workflow you're about to see. We have that basically as a bit of an intermediary step because we're actually copying everything from the institutional repository into the cloud. So we've got that additional data anyway, but this is a way of filtering out known ETCs. We're also, just to briefly mention, taking a replicated copy. So again, this is an automatic cloud thing, but we replicate a copy of all the data from the first bucket into another one. And we have what's called a Glacier archive tier store level on that, which is significantly cheaper. So it's a good way of having an additional copy for redundancy. So the workflow that we trigger, the ingest workflow, what does it actually do? So there's a number of things. It will check for duplicate submissions. So basically checks the checksum of the APE package. Have we had it before? If so, then it just basically doesn't ingest it. We just make a note of the fact we've received it, but we don't do it again. It unpacks the package because it'll be a zip file, but also it then recursively unpacks any containers within it, which is really nice. So this is actually given us a bit more insight into stuff that's in the institutional repository, because people might have supplied supplementary data that's in a container, a zip file, etc. And then it just goes in as a zip and we can't see what's in it. But this actually extracts, I think, to a predefined level. I think we said about 3 levels, because obviously it could go on quite a long way if you have a lot of embedded containers. And it makes all those files accessible to be individually scanned by the workflow and then visible at the repository. So we pass any supplied metadata. So we're pulling metadata out of, in the case of these 8 packages, a METS file. So it's nice structured data. We scan for viruses using ClamAV, built as a microservice. We identify file formats using Siegfried. So I think some parallels to UCC here. We then, in the act of submitting it to Fedora, Fedora allows us to basically verify, recalculates and verifies checksums. So one principle we have is we always capture checksums right at the start of acquisition. We pass those through, so we've got a chain of integrity. And on submitting it to Fedora, Fedora then basically checks its own calculated checksum against what you've supplied and make sure they match. And if there's any discrepancies or errors, it will actually error the workflow, and you can see that status and then go and fix it. This might not mean anything to people, but it creates a version in Fedora OCFL. So this is basically effectively making it immutable, creating a version. It's a concept in OCFL which Fedora supports. And it tracks the changes in a workflow database table. This is how the actual AWS architecture looks. Again, I appreciate this might not mean anything to people, but if it does, this gives a little insight into the actual components that we have running, and some of the services that we use. For example, you can see at the start of the bucket I mentioned earlier, that's where things first go in. We use a service called Event Bridge to basically detect and do something when an object arrives. The workflow is built, and it's perhaps underselling it with a small single icon on a diagram, but step functions here. That's the real brains of the operation. I will show you a glimpse of how that looks in more detail in a moment. The step functions is basically AWS's native workflow orchestration tool, and it's really nice. It allows you to define workflows in JSON and basically pull together all these different 200 plus AWS services in any way that you wish. So the only limit is your imagination. But crucially, that can include Lambda functions, and Lambdas are basically code that you've written yourself that can do the more complex and they're the glue basically which tie things together. What this diagram does hint at as well is how we've done the various what we term microservices, but I think is not strictly correct in terms of the definition. But again, basically using the same event-driven model, at some point during the step functions workflow, files that have been individually extracted will get dropped into a processing bucket. And that in turn, through the similar things, triggers a chain of events. Event Bridge drops a message in a queue. A queue in turn triggers a service to spin up a little instance of those two services I mentioned, so Siegfried and ClamAV. And they in turn have within their containers, they have like handler scripts, which will take care of pulling in the file, passing it to the service, getting the output, formatting it in a way which we wish, writing that metadata into the file of the object in the bucket, and then passing it on. And then at the end, you get these objects, these files with the metadata built up in them. And before we submit it to Fedora, we read that out again, and it all gets put in and nicely structured. Oh, there's a QR code there. So we have actually delved into this a bit more in one of our digital preservation blogs. So if you are curious, do have a look. This is just a sort of a brief glimpse, really. So if you are using step functions, every time one executes, it will actually show you what's happened in this very nice visual diagram. So I've not created this diagram. This is just generated by the step functions service. This one's all green because it ran successfully, but equally, if there'd been a problem, it might have gone red at some point. And you can see the chain of logic there. Now, I've deliberately chosen our submission step function, which is a very small one right at the start, because the main one is considerably taller and would not be remotely legible on the screen. So that gives you a little flavor of it. So I mentioned a version 2 of the workflow. So like I said, that MVP, that initial workflow we built, served us very well. It seems stable, it's working well. We did a big initial ingest of like a backfill of eThesis data, and we're continuing to do sort of BAU every time the export process runs. But we have grander ambitions. We want to ingest content from the whole institutional repository. We have Born Digital from transfer and deposits, as you saw, a digitization workflow, a digital library, etc. So what we built to begin with is quite monolithic. And in fact, I'm going to come back to that because I've got a nice diagram to show you. But just to touch on what version 2, what's changed. So this is a workflow we've just finished building, a few tweaks, but it's now basically working and operational. It's not live yet, but it's working in our development environment. The key difference is that we've re-architected that first version because it was very monolithic, and to spin it up independently for other sources, it would have basically duplicated a lot of code. The management overhead would have been significant. So it's designed to be more modular and enable component sharing and reuse rather than duplicating the code. Yeah, so we've modularized it into various components. The lambdas are sort of shared. The parts of that step function which copied to preservation and did the extraction of the containers. That's been split out. Anything which is sort of shared between them, sort of an executions table, a configurations table, that's deployed separately, and then any additional workflows just reference these shared components. Perhaps more excitingly, we've added in a third microservice for Apache Tika, which is a really nice tool for extracting embedded metadata from files and also detecting language. You can also use it for things like actually extracting the text of a file. We've not implemented that so far, but it will be relatively trivial to do so. We've also added support for ingesting content just for appraisal. Now, this is probably too in-depth for today's presentation, but this touches on our whole approach to how we're using Fedora and not necessarily versioning things straight away, as I mentioned earlier. This is a really nice way of getting stuff in as quickly as possible and having a place where we can actually do accessioning and appraisal. But it still gives us the option of discarding content, discarding it entirely, making changes to files, metadata before anything becomes immutable and actually sent to our preservation stores. But crucially, because it's all in the same system, we sort of have a continuous audit trail where all those changes are tracked right from the point it comes in. What else? We've removed the event store. I won't go into that, but it was something we implemented in the first one, which wasn't really used. And then crucially with this re-architecting, we can just add additional workflows with a very simple wrapper, because really the only difference between them now is where you get the content from and where you get the metadata from. So I'll just briefly show, there's a little diagram of how, if we'd scaled out using version 1 of the workflow, it would look something like this. The blue circled, blue outlined rectangles show basically where we would be duplicating code. This is obviously a massive simplification, but it gives you a sense of what would be the overhead we'd be adding every time. By comparison, version 2, the architecture looks like this. Not all of these are built yet, but you can see the components which have now become shared, and we're not having to basically maintain them individually in each of the workflows. And then the workflows themselves just become simple wrappers. And then we've broken out a number of tables into the sort of shared area. So this is, we've got one workflow working this way, our deposit service ingest workflow. We're about to add another one just to prove that it can be used by multiple. But so far all the indications are good and it's working well. I'll just finish with one final slide. This is probably going to be totally illegible at this scale, but if anyone's interested, that was just to show what some of these shared tables look like. So we basically have the concept of an executions table with each type of workflow, of which we have 2 at the moment. We have an ingest and we have a complete appraisal. That will invoke as it runs one or more of those step function executions. So these tables are basically a really nice way of tying together each invocation of that type of workflow, each one of which is given a UUID, a universal unique identifier, so that tracks it throughout the different steps. And it ties together the, I think, also UUID identifiers of each individual execution of those different modules of the workflow. And then crucially, it captures the sort of the output. In other words, the thing we've put in, what's its address, obviously the final status, if it failed, what the reason is. And these tables are useful for basically tracking what's going through these workflows. And we're going to be showing them in our user interface, which I won't show you today, but basically gives a view of what's going through the system. And obviously you can then filter down to your workflow of interest if you want to drill into what's come in recently and if there's any errors, etc. Just a quick honorable mention for, let's go back one slide. You might have seen it there, the complete appraisal workflow. So this is kind of stuff comes in but doesn't get preserved. I mentioned accessioning and appraisal. So once that process has happened and we want to send it to preservation, that's where that workflow comes in. Again, I've not got any more detail on it here, but it takes care of doing things like removing various metadata flags. It will verify that various minimum required metadata is present and valid. and then it takes care of the copy to preservation part of the workflow, which again would normally be invoked as part of the overall ingest. So this model actually scales nicely and is adaptable to other areas, and it's working really well. How are we doing for time? 20 minutes. I'll just briefly finally say, because I only touched on it. Another thing this does when it submits to Fedora, Fedora has the concept of transactions. So this is quite important from an atomic point of view. Basically, we didn't want a situation where stuff's going into our repository, but then something goes wrong, there's an error, and something times out, and then it's left in a sort of half-submitted state, which would be really messy. So a transaction within Fedora allows you to open the transaction, do everything you need to do, and close the transaction. And only at that point does it get written to disk. And everything has to succeed or nothing succeeds. And if something fails, it just automatically rolls back. The step function shows that execution of the step function shows an error, and then we can go and investigate it. But crucially, there's nothing, we can try submitting it again and make it happen cleanly. But if it doesn't happen cleanly, it just doesn't go in. That's been really, really useful for sort of enforcing some sort of discipline with the data that goes in. Okay, I'll stop there. Hopefully there's a couple of questions.
Yeah, thanks, John. That was really impressive. Thank you very much for that. The virtual applause has already started, and you've already got a couple of quick questions. Well, they may not be quick, but one from Faith. So, how would you advise an organization that's at the start of going digital, considering resources, both human and financial? What are some of the best systems to use whilst handling vast data? That's quite a big question, Faith, but have a go, John, see what you can do.
Hello, it's like being an interview. Let me have a look. How are you starting? What are some of the best systems you? I'm not sure I can answer that succinctly. I will say, in terms of our choice of the cloud, it was a sort of institutional decision to sort of take this approach. The cloud generally has, there's pros and cons, there's arguments for and against, but generally speaking, there are economies of scale. A lot of this, the way it's designed under the hood, is designed to sort of, be as cost effective as possible. And even if it isn't, the tools which the cloud provides us, the level of insight, crucially, it offers a lot of opportunities for cost optimization, which we've done a bit of so far, but we'll certainly be doing more of as we go through. And in terms of architecture, the way we can spin things up and down, that's a big cost saver.
Can I follow that up, John? Actually, but just
yeah. So I'm not really
maybe I missed it.
Just scratching the surface.
Well, I was going to say, so you said this is part of a 5-year program, isn't it? How far through that program are you, and how many John Gostics are there behind the scenes working on this? I guess what if you could.
We are roughly, I think, just past 3.5 years through now. So we had a bit of a slow start, sort of figuring out how we were going to approach it, but we've really been sort of hitting the ground running recently. In terms of implementation and team, there's myself, and then there's 2 full-time developers in terms of the team, with occasional help from another. We've also got a digital preservation team. I think Kaylin's in the audience, who sort of look after that side of things with the business. But yeah, it's a relatively small team. We are leaning heavily on obviously the work of others and open source and everything. Also, we're trying to sort of maybe I can actually segue nicely into Andy's question: bigger shift in mindset. I think you'll probably know this because he's been on some of our technical advisory groups and similar. But one big shift we made with a view to obviously it being in the cloud, but also the sheer scale of the data which we're potentially down the road going to be storing. The traditional model of fixity and checking, pulling the data out, reading it, calculating the checksum, checking it matches what's stored in your database, in your metadata, and then if it's okay, then signing it off. We didn't really think it was going to scale or be cost effective the more we had in this sort of platform. So we are leaning heavily on the vendor. So I don't want this to sound like a sales plug, but these vendors but due to their size and scale, they can do things like this better than we ever could. And they do offer SLAs where you're talking 11 nines, so 99.99s of durability and resilience of data. So we basically trust the vendor to, once we've given them a file, and as part of giving them, we get them to verify the checksum again, which we supply. Once that's all verified and stored, we basically say, right, you will now look after it, and we're going to trust you. That's not going to change. What we do instead is what we call a reconciliation process, where we take inventory reports from each of the cloud stores, basically look at the metadata and check that the objects are present and that uniquely identified by the checksums. And then we do like a three-way comparison. So we have multiple stores, and we basically take these 3 reports and just check that it's like a three-way comparison, check everything's there. And if something's missing or a checksum doesn't match, then we can do a recovery process.
Thanks, John. There was a question that was asked about whether you're going to share your slides, and I'm, as a more general thing, I'm hoping to work a charm offensive after this and see if I can encourage all the speakers to share their slides with us and we can put them up on the site. But if not, I guess, Mary, you could always try emailing John directly and sweet talking him. But Sarah, just last one then, I think Sarah Gentile asks,
I've just spotted it, yeah.
Yeah, about being tied to AWS.
Yes, so that is a fair point. So yeah, so not just lambdas, but I think step functions as well. There's a lot of very AWS specific services that we've leaned on here. I mean, I'll hold my hand up. We don't have a sort of migration plan. If we had to do it overnight, I don't think we could just do it, spin it up the next day. However, I think similar platforms like Microsoft Azure, they do have equivalents. And the actual code that's running inside the Lambda, for example, is Python for the most part, which is another widely used open coding language. So I think we'd be in a reasonably good position, perhaps within about, I don't know, a couple of months to be able to convert it to run on a different cloud platform. But obviously, yeah, there are platform-specific quirks and things that would be things we'd have to take into account.
Thanks, John. Thanks. Well, in the interest of being fair to everyone, I think I'm going to move it on now, if that's okay, John. But I guess some of the conversation could carry on in the chat. Thank you very much.